This lesson is on composite functions. If you have not watched the video function notation, I would stop this video and go back to function notation, because in order to completely understand how to do composite functions, then you need to understand what function notation is. If you have already watched the function notation video, then let's begin. As you remember, function notation is just a way of expressing some kind of function rule. So for example, here I have f of x equals x plus 3. So this function takes all of the x values and adds 3 to them. Composite functions is a way to blend two functions together. Think of the word composite. Like when you look at the composite pictures in the hallway of the graduating classes, we call those composites because it's a compilation of all the students who were in that class. Here are some examples. We are going to answer questions using the functions f of x equal 2x plus 5, g of x equals negative x minus 6, and h of x equals x squared plus 1. We're now going to evaluate what we call composite functions here. So look at this. This is read as f of g of x. To evaluate this, start from the inside out. Start with g of x and evaluate g of 4. So in this case, g of 4 would be negative 4 minus 6, which is negative 4 minus 6 is negative 10. We are then going to take negative 10 and we're going to insert it into the f function, which was 2 times x plus 5. So f of negative 10 is 2 times negative 10 plus 5, which is negative 20 plus 5, which is negative 15. That is f of g of 4. So again, start from the inside and work your way out. So let's try the next one. G of h of negative 2. I'm going to start by evaluating h of negative 2. I'm going to ignore the g function for a second. H of negative 2 would be negative 2 squared plus 1. Remember, if you're squaring negative 2 on your calculator, you need to be sure that you put parentheses around negative 2. So h of negative 2 is positive 5. I'm then going to take positive 5 and insert it into the g function. So g of 5 is negative 5 minus 6, which is negative 11. Okay, I want you to try some of these on your own. You try. Given f of x equals x minus 3 and g of x equals 10x minus 6 and h of x equals negative x squared, evaluate g of f of negative 4, and tell you what, I'm going to change this one. I want you to do f of h of 3. So press pause and then evaluate those functions. Okay, so the first one, you should have gotten negative 76 as your g of f of negative 4. If that's what you got, congratulations. We can fast forward to the next example. If not, then I'm going to work it out. So we're going to start with f of negative 4. F of negative 4 equals negative 4 minus 3, which is negative 7. So we're going to take negative 7 and we're going to put it into the g function. So this is going to be g of negative 7. So we'll do 10 times negative 7 minus 6. Well, 10 times negative 7 is negative 70. Negative 70 minus 6 is negative 76. Okay, for the second example, f of h of 3. Well, you should have gotten negative 52 as your answer. If you got negative 52, great, fast forward. If not, then stick around and let's watch how it's evaluated. So start with h of 3. H of 3, oh gosh, I think I looked at my key wrong. This is what happens when I evaluate stuff wrong. Let's do this all together. H of 3 is going to be negative 3 squared. I think I evaluated 7 squared. I'm trying to work this on the side with my calculator. Negative 3 squared is negative 9. And then we're going to plug negative 9 into the f function. So f of negative 9 will be negative 9 minus 3, which is negative 12. Sorry about that, or for any confusion. F of h of negative 3 equals negative 12. Okay, next example. We're going to do composite functions with expressions. This gets a little tricky, but if you stick with me and you're very organized with your work, then it shouldn't be a problem. So this is question C and question D, and it goes with the first functions I gave you. So f of x equals 2x plus 5. G of x equals negative x minus 6. And h of x equals x squared plus 1. We're going to evaluate f of g of x. So what this means is that you're going to take the g function and literally insert it into the f function. So wherever you see an x, you're going to replace it with the expression negative x minus 6. So here's how I do it. The color coding might help you. If the f function is 2 times x plus 5, I'm then going to take x, notice I put parentheses there, I'm going to fill in the parentheses where x was with negative x minus 6. So I have inserted the g function into the f function. Then you're going to simplify that expression, because right now it's kind of messy. I'm going to distribute 2 to negative x and negative 6. So that's going to be negative 2x minus 12 plus 5. And then simplify, so negative 12 and positive 5, those are like terms and they can combine. So this is going to be negative 2x minus 7. That's the composite function. Okay, let's try it again. H of f of x. Since f of x is on the inside, we're going to take f of x and insert it into the x on the h function. So my h function is x squared plus 1. So I replace the x with a set of parentheses. Instead of using x, I'm going to take the f function, which was 2x plus 5. Now I need to simplify this. So remember, whenever you square an expression like this, we're going to expand and FOIL. So when I expand this, and I'm going to move my work down here, 2x times 2x is 4x squared. 2x times 5 is 10x. 2x times 5 is 10x. 5 times 5 is 25. And then don't forget that plus 1 at the end. Now we're going to collect like terms. 4x squared is the only squared term in that expression, so it stays the same. 10x plus 10x can combine and become 20x. And then 25 and 1 can combine and become 26. There you go. The composite function is 4x squared plus 20x plus 26. Okay, I want you to try on your own. Evaluate f of g of x and h of f of x. So press pause, and then when you're ready to check your work, press play. Okay, f of g of x. If you evaluated it correctly, you should have gotten 10x minus 9. If you evaluated f or h of f of x correctly, you should have gotten negative x squared plus 6x minus 9. If you got these two composite functions, and congratulations. If not, keep watching, and I want you to see if you can identify where your mistake was. Okay, f of g of x. So we're going to take 10x minus 6 and insert it into the f function. So the f function was x minus 3. So I put parentheses, and I'm going to fill in those parentheses with 10x minus 6. 10x minus 6 minus 3, well, negative 6 and negative 3 are like terms, so this will be 10x minus 9. And that's it. Okay. The second example, h of f of x. So we're going to take the f function and insert it into the x on the h function. So the h function is negative x squared. So I put parentheses, but I made sure I kept the negative and the squared sign. And I'm going to fill in those parentheses with the f function, or the x minus 3. Okay, order of operations says that we're going to do the squaring first, and then we'll multiply by the negative. So this will be negative x minus 3 times x minus 3. And we want to FOIL this. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So this is negative x squared minus 6x plus 9. And to make it even more simplified, I wanted to take this negative and distribute it to all three terms. So this is negative x squared plus 6x minus 9. All right, so that concludes the composite functions lesson. Make sure you review your notes, bring your notes to class, and be ready to go over any questions.